Hey guys, it's Mr. Rysz. So we're going to start, no, we're not going to start. We're going to finish 114. So we got 3 activities to do. We got part 3, part 4, and part 5 to do. And so let's jump right into it. So we got a spinning spiral graph. Here we go. So we're going to wait till we complete step 9 to submit this code, but we'll do the best we can. So you can consider a loop as repeating a set of numbers, a set number of times. For example, you may want to draw 5 circles. You can set that in a loop to create 5 circles. So examine the code. Let's see what it does. So I'm going to move this over here. Well, we have spiral space equals 0 to start off with. And while spiral space is less than 80, we're going to go to that point. We'll move forward that many spots. Or plus spiral space times 3. So we're going to add that amount every single time. And each time that's going to get bigger and bigger and bigger. And then we got a modulo 18 equals Navy, modulo 18 salmon. So let's run it, see what it looks like. So it looks like the first 18 circles, yeah, this gets going around in a spiral, gets bigger, bigger, and bigger. The first 18 are salmon, and then the next 18 are blue, and then it switches because it's divisible by 36, back to salmon, and then back to blue. So what did we observe? Okay. The spiral's out of control, bigger and bigger, bigger spiral. All right, so what we're gonna do is modify the code that every 5th and 10th circle changes color. So in this case, it's every 18th and 36th. So we're gonna do every 5th and 10th, and the spiral is tighter and the circles are close together. It fills the screen without going off. Okay, so I'm gonna open this up in a new window here just to have more room to see and visualize. Okay, so the first step is let's change every 5th and 10th. So we have every 18th and 32nd, so I'm going to change that to 5, that to 10, and I think it said to change the colors too. So instead of salmon, let's make that blue. So where I see salmon, I'm going to change it to blue, and then, yeah, navy is basically blue. Can't you tell the difference? We'll say yellow. Run it. All right, so yeah, if we count 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, so every 5th, and then every 10th, it starts changing colors. All right, now they said they want this closer. So if we look at, we don't want them to move as forward as much as normal. So this is moving forward 50 plus the spiral face times 3. What if we just make that times 2? How does that get us closer? Okay, closer. What if we did times 1? Are they, they're kind of overlapping, yeah. Well, we can adjust this a little bit here, times 1.5. All right, there we go. And it seems like most of this stayed on the screen, so I'd say that's good. It's kind of a neat pattern that I made right there. Okay, so that's good to submit. We can move on to the next part. Part 4, nested loops. There may be times you want to do more complex algorithms that involve not only repeated steps, as in your spiral graph creation, but a repetition of repeated steps. You can place a loop inside of another loop to create powerful algorithms that perform many tasks in small, concise amount of code. A loop within another loop is called a nested loop or a nested iteration. So we can have outer loops and inner loops. So if you look at this example here with some pseudocode, we have like while j is less than some number, we increment j or we make it bigger. And then while I is less than some number, we increment I. So what this does is the I will loop and do its thing. And then once it's done, j will go up and then I will start back over and over again. So we're going to look at this code here and see what it does. Okay. So while j is equal to 0, while j is less than 10, we're going to make j go up by 1. That's what the plus equals means. So that's probably something new. In fact, I'm going to open this up in a new window here so we can look at it even closer. This plus equals is the same thing as j equals j plus 1. So yeah, j equals j plus 1. It literally does the same thing. It's just quicker to type. So we're going to print out what the value of j is. We're going to make I equal to 0, and then we'll make I. So what's going to happen here? Let's run this and see the results. So we start out, j is equal to 1, then I is 1, 2, 3, 4, 5, and then j goes to 2. I is back to 1, 2, 3, 4, 5. So this loop will repeat itself, and once it's done, then j gets to be moved back over and gets repeated. So this loop goes on until it gets done. Then the next iteration of J, the J loop, starts again. All right, so run the program to see if your prediction was correct, which we kind of said. For each iteration of the outer loop J, the inner loop iterates 5 times. Since the inner loop iterates 5 times for each iteration of the outer loop, the value I prints the values 1 through 5 a total of 10 times. Let's observe the while loop example and predict the output. So let's look at this one again. I'll probably open this up here in a new window. So we got a turtle here while X. All right, while X is less than 200, okay, so we're gonna make X go up by 50, make Y is 200. We'll make it go to that location and place a stamp. Okay, so this loop, there's no nested loop here, but we got Y, X starts at negative 200. What's gonna happen is we're gonna go to, well, it's gonna start out here. We're gonna make X 50 more, so it's gonna be at negative 150. Y is going to stay at 200, and we're going to go to that location. So negative 150, 200. We're going to make the color red and stamp it. It's going to repeat again. So we'll make it 100 now, negative 100, and stamp that again. So let's run this, see what happens. What happened? Nothing. Oh, there it is. Oh, okay. Let's run that again, see if we can see what happened. Somewhere. Oh, maybe I should make Y a little bit smaller. I'm going to just change this because I think I'm zooming too much and make Y 20. There we go. 1, 2, 3, 4, 5, 6, 7, 8 times. You can think about it here between, it starts out negative 200, then negative 150, 100, negative 50, 0, 50, 100, 150, 200. So here we go. All righty. So that go through? Yeah, I kind of did what I expected. So what we're going to do is create a nested loops here. Add the following code as an inner loop and predict. And let's run the code here. So let's copy this code down. Go back to our Ripple here, and we're going to add it as an inner loop. Let's see what happens here. So what it did, we'll make sure we put this in the right, but add the as nested inner loop and predict how to run the code. Okay, so I just put it at the end here. So we went over, we stamped the red, and then while what we did next was make the while. So let's actually change. What if we do Control X? Won't do. So he goes over, stamps it, stamp, 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 stamp. Now, what happens is here, there's nothing else that happens to the Y. So the Y moves down 50, and then it goes through again to check to see, and then it fails the first iteration. So let's copy your nested loop program into a new file. Let's modify the algorithm so that the nested loop stamps the turtles using the colors from left to right in the pattern instead of top to bottom as shown. The purple stamp represents the outer loop and the orange recall. Okay, so how would we change this? So this takes, instead of stamping it top to bottom, we're gonna go left to right. And we wanna change the colors from orange to yellow. Is that what they want? Or purple and orange? So the outer loop is gonna be purple. And the inner loop is going to be orange. And this time we want to stamp down. So let's think, if we're going to be moving down here, we're going to be talking about like the Y. So let's make the Y some number here. Let's just start out with like Y is equal to 200. And actually, let's go back. Yeah, 200. And how many rows do we have to go down? 1, 2, 3, 4, 5, 6, 7, 8. All right, so let's make it like Y is greater than negative 200. So we're going to start up at 200 and we're going to go all the way down to 200. We're going to make Y equal to Y minus 50. So each time we're going to go down 1. We don't want to make X. We'll make X equal to 20. Or let's just make it 0. All right, now here we're gonna change our X because we wanna go left to right. So while X is, let's see, greater than, actually we probably want it to be less than, let's see, 20, let's just do 200. We probably have to change this number here. What's my numlock go off? There we go, oh, not 2000. We're gonna make X up by 50. Let's run that. All right, we're stamping left to right, and I think that works. Now we just got to double check that we have enough. Probably not enough there. So we're going top to bottom this way, and we're moving left to right. How many rows do we got? 1, 2, 3, 4, 5, 6, 7, 8. But how many over do we go? 1, 2, 3, 4 oranges. We want to have 1, 2, 3, 4, 5, 6. So we need to have 2 more sets of oranges here. So you think about here, X, we're starting at 20, we're going up to 200. So let's just do 300. That should give us. Oh, I just put 30. 300. One, 2, 3, 4, 5, 6. There we go. So we had to switch the X to Y's around. We had to change whether they were adding or subtracting. We also had to change the colors. So go ahead, submit that done, and we'll go to the last one of 114. So we're gonna observe another nested loop here, predict the algorithm, and we'll submit this when we get through step 19. Okay, so I'm gonna open this up here, and well, I can leave this open a little bit here. Let's look at this code. Well, let's just run it, see what happens. Okay, so he's going and he's drawn like, was he drawing tick marks or was that just my screen? I think that's just the screen. All right, so it goes over, makes a diagonal line, goes down. Okay, so we look here while X is less than 0 and Y is less, we're gonna make X equal X plus move X, which is 1. Y, so the X moves up by 1, the Y moves up by 1. And then once this loop gets done, once Y is less than 100, we're gonna switch Y to negative, or the move Y to negative, so now it's moving down. Okay, so what we're gonna do is recreate the nested loops here to run the program and compare. All right, so what, okay, that's what we did. They want you to put this in your own separate one. 17, modify the code so the outer loop draws 2 peaks as shown. So what would we have to do to this? Well, we could do this again, couldn't we? Or is there a way to just modify the loop itself? I mean, the easy way to do would just be like, okay, Control C, Control V, and then we'll just, actually, I'm not even sure if that will work because it will change, right? Okay, that doesn't work because the X's don't get iterated. Okay, so let's get rid of that. Sorry, my kid's going crazy right now. All right, so maybe while X is, what happens to X? X equals, oh, move X. Maybe go to 2. Let's see if I change that to 2, what happens? All right, so we just had to make the X go to 2 because the first starts out with 0, or wait, was it a 0? And then it gets increased to 1. In fact, I wonder if I do 1. Hey, Bowie, can you be quiet? Oh, we just had to change that to 1 because it will stop. Okay, so there's 17. Next, I think that's the hint there too. The condition that compares with the X. All right, write another loop. So after the first one is done, the turtle draws an additional pattern on the opposite side. Let's look at the hint. Let's experiment with the X, Y, and move values. Okay, well, I'm just gonna go ahead and copy and paste this over everything. Now, if I do this, what's gonna happen? Let's run this and see. He goes up and down. God, I'm sorry, my screen is. And then he's just gonna go move right back to the beginning and do it again. Okay, so we don't want him to go back to the beginning. We gotta figure out, okay, where is he ending right here? So that's gonna be our new X and Y. So he ends, let's see, X starts at negative 200, and we keep going over. So where is that starting location? So let's see, Y ends at 100 and then it goes down. So Y is at 0. We still want to be at 0, but X, is that at positive 200? Let's run it and see. We're just changing the X and Y location. Make sure we begin. Okay. So, okay, he stops right there. Now, he isn't moving anything else. Next, what we want to do is make sure that, okay, while X is less than 1, let's switch this around here. No, that doesn't work. Maybe instead of being less than 1, we make it greater than 1. And let's see, let's run that. Now this might be an infinite. Bowie, I need you to be quiet. That's the opposite of quiet. All right, now I think I just made a loop that goes on forever. Okay, because each time we do this, we're adding 1. So we need to make sure we initialize move Y is negative 1 at the beginning, and we'll switch this to a positive 1. All right, so let's run this. Let's see what happens. Up, down, up, down, and now, okay, down. Ooh, okay, he keeps going down. He doesn't go back up. So what isn't that? What's going on there? That's got to be the while. So while Y is, okay. It's always going to be less than 100. So let's make sure it's greater than negative 100, because that's the lowest that it's going to go. So now it gets down to negative 100. Ooh, and it stopped. We want the move Y to switch back to positive. Ooh, but I think we get a stop here. Maybe less than 0. Yeah, there we go. Run that again. All right, goes up, down, up, down. All right, can we start going backwards? Okay, there's negative 100, but now it's switching. Ooh. All right, so we want to make, oh, I think this while loop is not enough. Maybe 2? Oh, wait, no. No, that wouldn't make sense. Maybe. We need to do one more peak here. So let's try to edit this loop here. X is 200 while X is greater than 2. Now, what's going on? We're making the Y move down. We'll make an X equal. Okay, so we make the X smaller. Maybe while the X is just greater than 0. Did I not have 0 there? So X is always, okay, so we go through the first loop. Now the second part, X starts out as 200 and that's always bigger than 0. We're making the Y go down, down. Now what should happen is the X is still like right here. Oh wait, here's the problem, I know. This X location is at negative 200. So we got to make sure we're greater than negative 200. All right, so this would have been easier if I had graphed this out on a grid. This is at 0, 0. And we're going to map it out. So I made this tougher than what it should have been. If I were to realize that this was a coordinate grid at 0, 0, this would have been way easier. I was assuming this was 0, 0. Okay, hopefully that helped you guys out. You watched the video if you were stuck. If you had any questions, just ask, but I'll see you guys next time.